Well, hello! Today I'm going to talk to you about columns in AG Grid with React. We will use this application here for this video. We can see a bunch of column definitions here, loading data from the server here, and then here is the AG Grid React component. Now these columns only have a field specified so far. In this video, we're going to go nuts with lots of different types of column configurations. The grid generates header names by looking at the field and assuming camel case. So for example here, athlete will be replaced with athlete with a capital A. We can see that up here. If the field consisted of a few words in camel case, for example athlete 2, 3, then the grid will reverse the camel case and display the words as you can see here, athlete 2, 3. You can also explicitly set the header name using the column property header name. Here I'll set the header name to competitor for the athlete column. So now header name is competitor here, and it's competitor also at the top of the column. It's common to allow columns to be resized. That's achieved with the resizable column property. Now that I have resizable set to true, a drag handle has appeared over my column. If I click this with the mouse and drag, the column is resized. I am now introducing the default call-def, which will allow me to specify properties across all columns. Here is the default call-def defined. I've bound it to the grid property, default call-def. You'll notice that I have resizable set to true in the default call-def, and I do not have resizable set to true in any of the column definitions. In the demo running, I can see that there is now a resize handle on every column. Every single property that a column can take can also be put on the default call-def. You can specify width for a column. Here I've specified width 100 for age. That's 100 pixels. Here on the right I can see the age is 100 pixels wide. The default column width is 200 pixels. That's why age is now half the width of the other columns. You can also specify a minimum and maximum width. For the age column I now have a minimum width of 80 pixels and a maximum width of 200 pixels. When I try and resize the age column, it will not let me go smaller than 80 pixels or larger than 200 pixels. Now let's bring width 100 pixels down to the default call-def. So width 100 at the default call-def means all of the columns here. I've got width 100. Now there's a scroll bar down here for me to view other columns. Let's say I wanted to get rid of that scroll bar and have the columns flex. That's done by specifying a flex value. Here I'll specify flex equals to 1. Flex 1 here set at the default call-def means that every column is flexing with a weight of 1. In our demo we can see there is no horizontal scroll bar and all of the columns are the same width. You can have different flex weighting values. I'm setting flex now to 2 for the competitor column. So competitor is flexed to 2, all other columns through the default call-def are flexed at 1. That means that the competitor column will be twice as big as all other columns. If the width of the grid changes, then the flex columns are recalculated. For example here I'll maximize my browser and the columns are still fitting the width of the grid. Competitor is still twice the width of the other columns. If I bring my browser back to the original size, again the column widths are updated. I can also resize an individual column. So here I will resize competitor and you can see that competitor will now stop flexing and the other columns will take up the rest of the space in the grid. They will flex to fill that space. Now it's only the columns to the right which will flex. So if I for example resize year, you'll see that it's only to the columns to the right which will change width. And any column that I specifically resize will no longer flex. So for example, if I resize age here, you'll see all of the columns to the right will change width except year, because with year I already gave that a specific width, so it's no longer going to flex. Right, enough about flex. Let's go and talk about editing. A column is made editable with the editable property. With editable true on the competitor column, if I now double click on a cell inside competitor, I can change its value. A column is made sortable with the sortable property. Now it's sortable set to true on competitor. If I click on the column header, the rows are sorted. I'll move editable and sortable down to the default call-def. We can now edit any column and sort any column. Oops, I just realized this use memo. I forgot to put in my dependencies. An empty array. Right, our little secret, don't tell anybody. Okay, let's go back and talk a little bit more about the fields property. If your data record is not flat, it's possible to use dot notation. So here I'm saying the athlete variable is inside the bar object, which is inside the foo object, which is inside my main record. Which is not true for this demo, that's why the competitor column is now blank. Field isn't the only way you can provide values, you can use a value getter instead. A value getter allows you to give a value to the grid rather than the grid looking the value up using the field. A value getter is a function that returns a value. This value getter here is simply returning back a random number. That's why we now see random numbers inside the competitor column. The value getter is provided with this object here that I've called P. We call those params. I'm printing the params to the console. Let's take a look. Inside the params is a bunch of stuff that the grid gives us to help us pull out the value for the cell that the grid is interested in. Of note, we can see the data, which is the data item for that row, and the column, which is the column we're looking at. Now that we know this, let's make our value getter more useful. So this value getter is returning back the athlete attribute of the data passed into the value getter. So we can see now that the athlete is displayed again underneath competitor. So we're back where we started. This value getter is equivalent to specifying athlete as the field. So right now you might be thinking, why would you ever bother using a value getter if you can use fields? Well, that would be a good question. Well done for thinking about it. A value getter is useful when you can't use a field. For example, maybe the row data is an array rather than a flat object. Then the value getter might look something like this. You usually turn to a value getter when you can't achieve what you want to do using the field property. You've also got value formatters. Sounds like value getter, but it's not the same thing. A value formatter formats the value. So here I can see the value formatter is pulling the value from the provided params. It's then putting the value into square brackets. I can see then the competitor column on the right hand side is placing all of the values in square brackets. In the console we can see the contents of the params passed, and we see here again it's a bunch of good stuff that the grid gives us to help us with the formatting. Of note is the value that's passed to the value formatter. Let's pay attention to the order of things here. First, the grid will get the value using either the field or the value getter. Once it has the value, it'll then look for value formatter, and it'll call that if it exists. And then third, it'll put the value into the cell, and it will use a cell renderer if it exists. So if, for example, you're providing a value getter, a value formatter, and a cell renderer, all three will get used in the order, first the value getter, then the value formatter, and then the cell renderer. And cell renderers are discussed in a different video. Okay, moving on to pinning columns. And to do that, I'm going to take away flex, because to show pinning columns, I need to have a horizontal scroll bar. And let's take away this code here so it's not confusing us. Now let's say I wanted to pin the competitor column to the left. I would do that by setting pinned left on the column definition. Now you can see as I scroll left and right, the competitor column stays on the left. It can also pin to the right, which I'll show to you now with the age column. I'll set pinned right on the age column, and we'll see now as we scroll horizontally, competitor stays to the left and age stays to the right. You can pin by as many columns as you like. That's how you pin using code. Let me show you now how to pin using the UI. Let me take out pinned here, and I'll take out pinned here. We'll do refresh over here. Now nothing is pinned. Just say I want to pin by the athlete column. I'll bring it to the left. I'll keep it here, hold, and then bang. It's now pinned. So basically, if you drag a column to the edge of the grid, wait for about 2 seconds, then the grid will automatically pin by that column. I'll show you again. I'll refresh. This time I'll take country. I'll bring it to the left, hold, and there, it's now pinned. You can pin by as many columns as you like this way. I'll just drag another column into the pin section, and here now I can see that I've pinned by 2 columns. You can then unpin using the UI by just dragging a column out of the pin section. Here I've now unpinned. If we don't want the user to be able to pin via the UI, then we can use the lock pinned attribute. Over here, I'm now pinning left the competitor column, and I'm also lock pinned true the competitor column. That means that the competitor column is pinned, but if I try and drag the column out, I cannot. It will stay pinned. I can still change pinned on the other columns. Here I will drag age into the pin section, and that pin's fine, and I can unpin age by dragging it out again. If I want to prevent pinning on all of the columns, then I need to put locked pinned on all of the columns, or just simply put it on the default call def. Now I can see competitor is pinned, and I can't drag it out, and I can't drag any columns in. Perfect. I'm now going to show you lock position, because it looks like pinned, but it's actually got nothing to do with pinned at all. Let me take pinned out here, and now we'll lock position for the competitor column. Now the position of the competitor column is locked. That means if I click on the header and try and drag it, nothing happens. I can't move this column. Furthermore, if I try and move another column, like for example I'm trying to move age here, I can't move it before competitor. There's nothing I can do in the UI to stop competitor from being in the first position. You can also hide columns, like here I'll set hide on the competitor column to true. Now we can't see the competitor column anymore. It's gone. Hidden columns are useful because you can still do things like sorting and filtering the hidden columns, even though the user can't see the column on the screen. Also, if you're using AG Grid Enterprise, the user can unhide columns via the column tool panel on the right hand side. If you don't want the user to be able to hide and unhide via the UI, then set lock visible to true, like this. Now let's take these away to make room for the next topic. You can enable tooltips for a column by specifying tooltip field on the column definition. So here for the competitor column, the field is athlete and the tooltip is coming from country. So here I can see in the competitor, the athlete is shown in the cell. And if I hover, there we go. United States is in the tooltip. And just like you have field and value getter, for tooltips, you've got tooltip field and tooltip value getter. Here on the age column, I've specified a tooltip value getter. It takes a function. The function is provided with params, just like all the other callback functions we have in the grid. And in this example, I'm just returning back a random number. Not very useful in an application, but here it demonstrates an hovering age. There we go, a random number for the tooltip. And then to put a tooltip onto a column header, use the header tooltip attribute. So here for the competitor column, I've set header tooltip to be AG grid is great. And then when I hover over the header here, AG grid is great. Brilliant. Next topic is column groups. Let me write some code here to help explain. Just one cornetto, give it to me. Now in our running demo, you'll see here medals. And the medals consists of gold, silver, bronze in total. They are in a column group. That was configured in the column definitions with this object here. Now, instead of a column definition, I specify a header name and I specify children. Children here is the key. That's how the grid knows this is a group. If the children attribute is present, it treats it as a group. Then inside the children, we have column definitions as before. And then I just move these column definitions down towards the end to push this medals group over to the left-hand side so that we can see it all without scrolling. And lastly, I set width 100 to all columns so we can see more columns inside the demo. Now we can move columns just as before, so if I drag the gold column here, I can see it can be moved around. I can also move the column out of the group, and if I do that, you can see that the group is now split. I now have two column groups called medals. If I move another column out, I'll have three column groups, and then I can join these two together. So if two or more columns of the group are beside each other, then they will be included in the same parent column group. Now, some applications will love the way you can break column groups apart like this, and some applications will hate this. To stop this, set married children to true for the column group. Now, with married children set to true, if I try and move a column, it will not let me move the column outside of the group. It'll keep all columns in a group beside each other. Column groups get more interesting when you allow them to be opened and closed, like I'm coding up now. Here I have set column group show to open for the gold, silver and bronze columns. That means then in my demo, the medals will only show total when it's not open, and then when I open it, it'll show gold, silver and bronze. Total is visible regardless of whether the group is open or not. To have the total column not displayed when the column group is open, I set column group show to closed like this. So now the total column has closed for column group show and the other three have open for column group show. So on the right hand side here, I can see total is shown when the column group is closed, and when I expand, total disappears and gold, silver and bronze are shown. You can have as many levels of column groups as you want. Here I'll code up just a few more levels to demonstrate. Delicious ice cream from Italy. So here I've got the column group AAA with children of another column group BBB with children of another column group CCC with children, two columns looking at the age attribute. And here on the right hand side, that's exactly what we see. We see the top is AAA, the next BBB, then CCC, and then we have two age columns underneath. And then on the right hand side here, we can see medals is still there as before. Now you will note that the groups are balanced. That means that all of the columns appear on the same line. So even if a column does not have any groups, it'll still appear down at this level. Right, let's tidy up our code and move on to the next topic. Next, I'd like to show you using the Grid's column API. And to do that, I'll need to put some code in to get a reference to the column API. I love coding. Okay, so up here, I've got a grid ref and I'm using the React hook use ref. That's then linked up to the grid down here. I'm specifying the ref for my grid component and passing in grid ref. I've also introduced a button here, and when this button gets clicked, onPushMe is called. And onPushMe, I'm using the use callback hook, and it simply logs to the console. So if I then go to my example and click push me, it's working. I'll now change it so when we click our button, it will call the Grid's column API. So here is my new code here. I am calling get all columns on the column API, and the column API is found on the grid ref. And then likewise, get all displayed columns is on the column API, which is on the grid ref. In my other videos, you would have seen me use the grid API like this. Now there's two APIs, there's the API and the column API. They're very similar, the only difference is the column API contains methods for columns and everything else for the grid is inside the standard API. Now there is a bunch of API methods for columns in this video. I'm not going to go through them all, I'm just going to go through some. So here, get all columns, get all displayed columns. Let's see what they do. I'll click push me. Down here we see the result of all columns. It returns back 10 column objects, and then displayed columns returns back 7 column objects. First up, what is a column object? What you provide to the grid are column definitions. So here in our code, I can see what the column definitions are. Now these are immutable data structures that are passed to the grid. What the grid does is it will take each column definition, for example, the competitor column here, and it will wrap that inside a column object. So if we provide 10 definitions to the grid will create 10 column objects, each column object representing exactly one of the column definitions. So going back to our example, we can see all columns here. If we expand it, and then expand the first entry. So this is the column object that the grid created to represent the first column. Inside it, you can see it has a reference to a call-def. That is the column definition it's using for this column. If we expand the call-def, we can see that it's similar to the call-def passed in here. I say similar because this is actually the final call-def. What happens when the call-def is merged with the default call-def? So we can see here we have resizable, editable, sortable, and with. So they're all set here, as well as the items on the call-def up here. If you want to see what the application passed in, that's down here in the user provided call-def. And this is exactly as you see here. Now the call-defs are immutable. I did say that. And that's why the grid needs a column object. The grid needs to keep state about the column. For example, the column width can change. And when that happens, the call-def is still just the call-def, but the grid maintains state. Let me show you. I'm going to resize the competitor column, make it a wee bit bigger, and then I'll click push me again. Now if I expand the column for the first column, I can see that the actual width is 137. That means that the column is 137 pixels wide. However, in the column definition, the initial width was 100. Again, this column def will never change, but the column contains state information which does change as you interact with the grid. Another example of state would be the pinned attribute, which I can see down here. It's set to null. That means this column isn't pinned. If it was pinned left, a string left would be here, and if it was pinned right, the string right would be set here. Now we're looking at the internals of the column object. Your application shouldn't be using what's inside here because this could change between different versions of the grid. If you want to know how to safely interact with the column object, then go to our documentation and go to the column object section, and here you can see all of the public methods which are on the column object that you can use. So for interacting with columns, use a mix of the column object and the column API. Right, going back to our code, we have two methods here, get all columns and get all displayed columns. I will now explain the difference between the two. Get all columns will return back all of the columns in the grid. So if you have 10 column defs, like we have here, it'll return back 10 columns. Get all displayed columns will only show the ones that are displayed. So in our example, because this group here was closed, the gold, silver, and bronze will be missing from this list here. So displayed columns will return back the columns that are actually being displayed in the grid. If it was to open this group and click push me again, it'll now return back 9, which is all the columns except the total, because the total isn't displayed when the medals group is open. Now so far I've pulled back lists of columns using get all columns and get all displayed columns. I can also pull back a specific column, and that's done using the get column API. So here I'm calling get column and I'm passing in year, and then I'm printing this to the console. Then in my demo, if I click on push me, I can see the year column is printed to the console. So get column will return back the column object for the ID that you provided. This is a lot of information very quickly, so let's just take a breather. Ooh, stay focused. There's only 4 minutes left in this video. We're now going to talk about column IDs. We can see here that the grid gave this column an ID of year. By default, the grid will use the field for the column ID, and this will work most of the time. It won't work if you've got the same field used in multiple columns or if you're using a value getter. Let me show you with some code. Here I now have the H column listed 3 times. The first 2 is just using field, and the third time it's using a value getter, so there is no field. If I now push my button, it's printing out all of the columns to the console. And let's have a look at the first age, and I can see col ID is age. Then the second time, the call ID is age_1 because age ID is already taken. Then the third time where there is no field, call ID is 0. The grid is just assigning IDs starting at 0 and incrementing by 1 each time. If you don't like the column IDs that the grid is using, then you can explicitly provide your own using the call ID attribute of the column definition. Here I'm now providing column IDs age A, age B and age C, and I can see now in my console if I click on push me and go to the columns, here I have age A, then age B and lastly age C. Right, let's tidy this code up and go down and use some column IDs in the API. I'm now calling the column API set column pinned. I'm passing in the year column and I'm saying left to pin it to the left. So we can see here as the application loads, there's no pinning. Then when I click on push me, now year column is pinned to the left. Set column pinned here took the year ID. However, I could also pass in the year column from here. So if I copy and paste it in here, hit save and then refresh. So here I'm not pinning, click push me, now I'm pinning. So this parameter of the method set column pinned can be a string, which is the column ID, or it can be the column object itself. That is a quick introduction of using the column API to manipulate the columns. To see all the different things you can do with the column API, go to our documentation and the column API page and you'll see all the different methods listed here. You can also then click on one of the methods and see what it takes as parameters. So for set column pin that we just used, we can see it takes the column key, which is a string or a column, and then how to pin it, which will be left, right or null to clear it. For the key, it says here it can be a string or a column object. The string would be the column ID or the column object itself that we looked up via one of the other APIs. Now all of the methods here follow the same pattern. If you're doing an operation on a column, it'll allow you to specify the column using either the column ID or pass in a reference to the column object. Now, you are welcome to use the column API as much as you like. However, React developers prefer talking about state and managing state, and that is what I'm going to look at in my next video, column state. And that brings me to the end of this video, which was a whirlwind tour of column definitions. I hope you enjoyed it. If you didn't enjoy it, well, why are you still watching?